Welcome. This video demonstrates how I build my brass chassis cars. I hate long introductions found on many videos, so I will put those comments at the end. After many years of racing 1/32 plastic slot cars, I decided it was time to find something more robust and larger to race on my plastic track. Looking at many options, it was clear to me that the Carrera cars were just too large and really did not meet the durability I was looking for. Yes, we race very fast, which results in lots of rubbing and bumping, and even some cars going airborne. Don't get me wrong, pure scale racing is a big part of this hobby, but just not in my wheelhouse. Before Ninco left the slot car business, their X-Lot cars looked appealing. 1/28 scale met my size requirements, but X-Lot cars turned out to be very complex to set up and never really raced well. Nor were they very reliable in hard racing. But the X-Lot size proved to be what I was looking for, and many of their parts were a usable option. Of course, years later, they became a bit of a unicorn. Further searching revealed there really was very little available in this size slot cars, and nothing I tried met my durability requirements. I do love building and repairing slot cars, but not during a multi-hour endurance race where rubbing is racing. My quest led me to find the H&R Racing 1/24 scale chassis. Although it was too long, it was adjustable, and the wheelbase width was perfect for racing on any of the commercially available plastic tracks. After years of experimenting with different H&R chassis, I ended up selecting the HRCH09 as the starting point for my cars. I found that the narrow soft silicone rear tires gripped the plastic track well and raced many hundreds of hours before needing to be replaced. The front foam tires were super easy to sand down to size and really don't do much work if the front guide is set up correctly. When you remove the H&R09 chassis from its clear shipping bag, you will find it is a complete, ready-to-run analog chassis. The chassis comes with a plastic front guide, which is perfectly usable, but I prefer to change this to a graphite version. It will need to be sanded down to fit most plastic tracks. There is a small metal tab directly behind the front axle shaft that will have to be removed. I will show that later in this video. The axle shafts and width of the wheels are too wide for our final project. 2 black plastic spacers will be removed and replaced with thin metal washers. The next step in our project is to completely remove all the parts from the chassis. Once all the parts have been removed, we are left with the bare brass chassis. As you can see, the front and rear parts of the chassis are screwed together with 4 screws. As we will need to shorten the length of the chassis, we need to remove the 4 screws. On early versions of this chassis, there were enough holes that we could reuse 2 of them. Later versions eliminated these extra holes, so we will need to drill 2 new ones. Once we have separated the front and rear chassis parts, we can remove the tab from the front part. This is easily accomplished using a regular pair of pliers holding the tab close to the chassis and rocking it back and forth until it breaks off. The final dimension, center line from the front to the rear axle, needs to be 3 1/4 inches. The dimension was arrived at trying many different lengths, and this ended up overall racing the best. Looking at the bare chassis, the 3 1/4 inch measurement ends up from the center front axle hole to the center of the rear axle hole. This is because we will be using the center front axle hole in our final chassis. The next step is to mark the chassis parts where we will want to cut them. As stated before, they are too long and need to be cut off for our application. The rear chassis is measured from the back edge 2 3/4 inches toward the front. In the new version of the H&R product, this means we will be cutting off all the original mounting holes with our cut line just behind the last existing holes. For the front part of the chassis, we will need to make our cut 1 7/8 inches measured from the front edge of the chassis. It is always important to measure multiple times to make sure the cuts are in the right place. The old saying holds true: measure twice, cut once. The final front chassis part cut line should end up between the second and third set of holes already drilled in the chassis part. The next step in our process is to cut the two chassis parts to length. Although there are many ways to do this, including using a metal bandsaw, the simplest way is with a metal blade hack saw. For those who like using powered hand tools, Dremel makes two types of rotary cut-off blades. One is quite thin, is very flimsy, and can be difficult to work with. The other blade is much thicker and cuts our type of brass metal quite well. Please remember, anytime working with powered cut-off tools, proper safety equipment must be used, including eye protection, and I highly recommend a full face shield. Repeat the process for the other half of the chassis. Once both cuts are completed, it is time to clean up all the cut edges. This can be accomplished using a block of wood and sandpaper. 220 grit works quite well. The other option is to use a file. Both options work very well, but do take your time. It is important to make sure all the burrs left from the cut are completely removed, that the surfaces no longer contain any sharp edges. Remember, take your time with your cleanup. It is also my recommendation to round the front edges of the rear chassis part. This will make a cleaner look when finished and eliminates potential sharp corners from our cutting on the chassis. Now it is time to mark the two new holes we will need to hold the chassis together during the silver soldering process. The front half of the chassis will mount over the top of the rear part. The front part already has two holes that we can use. Remember, with the latest H&R chassis, we removed all the connecting holes in the rear section. If you find that you still have holes in the rear section, this will not be an issue, as you should be able to use two of those holes and save yourself from the next drilling process. Our goal is to have two holes through, both chassis halves that result in the center front axle hole to center rear axle hole being 3 1/4 inches. I find that using a black Sharpie pen to mark the holes works quite well. Finding the right size drill bit is simple. Just make sure it just fits in one of the front chassis section mounting holes. Using a center punch is always a good idea to help start our drill bit in the correct location. I also find it useful to use a scrap block of wood under the chassis so that we don't drill an unwanted hole in our bench top. Before we reassemble our front and rear sections of our chassis, in preparation for silver soldering, I find it beneficial to clean both surfaces where the solder will hold our chassis together. A wire brush does an excellent job, but you can also use 400 grit sandpaper or even a wire wheel on a rotating tool. I have reassembled the two chassis sections using two of the original 4 screws. It is a good time to check two things before we start soldering. First, the 3 1/4 inch axle-to-axle measurement is still correct. If not, now is the time to correct it. Second, that the front and rear sections are parallel to each other. Our slot car chassis will actually race well if the alignment is off, but it may look a bit strange. Once everything is correct, tighten both screws. There is no need for lock washers as these screws will be removed after the soldering is completed. The silver soldering process is next. I do this so that the chassis is as strong as possible without using mechanical fasteners to attach the front and rear sections. There is always the possibility for screws and nuts coming loose and can cause a lot of trouble during a long race. This soldering process is not difficult to learn and can be mastered by building your first brass chassis car. My preference is to use Stay Bright brand silver-bearing solder. It melts at a reasonable temperature and flows well into the gap between the chassis parts. It can be soldered using a propane torch, however I recommend using a butane hobby torch which can be purchased at many hobby, hardware, or big box stores. Begin the process by applying the liquid flux, making sure you allow it to flow between the chassis sections. Then apply the heat, starting by heating the area where the front and rear sections are screwed together. I like to hold my rear chassis in a metal vise as this area also has soldering, and we don't want to reheat and remelt this soldering. Once the overlap area is heated up a bit, you can focus the tip of the flame on one edge, heating it until the solder flows into the cracks. You can test the temperature by touching the end of the solder to the metal chassis, but keep the solder wire out of the direct flame. Once the chassis is hot enough for the solder to flow, add solder while moving the flame ahead of the solder wire being added and work across and over to the other edge. Don't rush. Take your time as you can always stop and reheat the area if needed to add additional solder. If you need to reheat the area, you may also want to add a bit more flux. Adding additional flux when reheating a soldering project is always a good idea. The entire process goes very fast. Once you have added enough solder wire to see the solder fill the gaps, you are done. Time to just let the chassis sit quietly and cool off. Some say that this soldering is the hardest part of building a brass chassis car, but I find it to be the most enjoyable. And if this is your first time soldering of this type, now you know how to use it on other household projects. After your chassis has cooled, it is wise to give it a quick bath in warm water and some household detergent. This will remove any remaining flux. I also like to file off any extra solder that flowed into areas which it is not needed. And now is a good time to remove the 2 screws and nuts which are no longer needed. Finally, I like to use my wire brush to go over the entire soldering area to clean it up a bit. Although not technically necessary, it does make for a brighter finish. The next step is only needed if you plan to run your brass chassis cars with magnets. At the end of this video, I will list my recommendations. If you are going to build several brass chassis cars, I highly recommend buying all your magnets at one time. This way, they will be closely matched, and the final cars will run close to each other. We will use CA glue to hold the magnets to the chassis. The areas that the magnets will be glued down to will need to be roughed up a bit. This allows the glue to bond very well to the brass chassis and will ensure the magnets do not come loose when racing. There are many options that can be used including sandpaper, but I like using my rotary tool with one of the available attachments. I find the best attachment is the metal burr bit or milling bit. It makes it easy to rough up the brass chassis and is easy to get into the areas needed to be roughed up. Don't get over-aggressive with this process. The surface just needs to not be smooth. Anyone who has worked with CA glue knows you do not want to get any of it on your hands. As much as I would recommend wearing gloves for this process, I find it easier to do this by hand, and just be very careful. Apply the glue to the chassis in the area that the magnet will be placed, and then slide the magnet into place. Just as a reference, I am using Sin Bad Thick CA glue. I find this manufactures CA to work extremely well, but any thick CA glue should be fine. Push the front magnet as far forward as possible, but keeping it flat on the chassis. Do not allow it to raise up on the front guide tab of the chassis. The magnet should be centered on the chassis, and a pencil can be used to help position it. Do not try and use any metal objects to help position the magnets. They will only stick to the magnets and make the alignment more difficult. Once the magnet is in its correct position, I use a plastic clamp to hold it in position. Although not absolutely necessary, I use CA filler material to help bond the magnets to the chassis. This is really just very fine sand-like material, however, does significantly improve the bonding of the magnet to the chassis. CA kicker spray may be used to speed up the bonding process, but I prefer to allow the CA glue to set overnight. This seems to make a much stronger bond. Repeat the process for the rear magnet. But before you do so, make sure that the rear magnet's polarity is the same as the front magnet. I don't really know if this makes any difference, but it does make some engineering sense to keep the poles of the front and rear magnets the same. The rear magnet should be positioned as far forwards as possible and touching the rear part of the motor mount. This is key when we reassemble the rear axle. Time to take a break. Let the chassis sit overnight so that the glue has time to completely set. The next day, you will almost have your brass chassis completed and will be ready to reassemble all the components. But first, you will need to determine what body you will be using on your chassis. I have used 2 different types very successfully, but I am sure there are others. The body just must fit over the chassis and wheelbase. As we discussed at the beginning of this video, this chassis was designed to fit under a Ninco X-Lot body. If you are lucky enough to find one or more of the Porsche Ninco X-Lot bodies, then you can also use the Ninco Body Mount Kit to complete your project. You will need to drill 2 holes into each of the side wings of the chassis and screw the body mounts to the chassis using these holes. I am not going to spend a lot of time detailing this process, as it is really quite easy. But, as we also have discussed, the Ninco X-Lot parts are really unicorns to find, and you most likely will be on to Plan B. Plan B has become my body of choice as they are available and hold up very well to hard racing. Up to the time I am making this video, late in 2025, the H&R chassis kit come with 2 aluminum body mount brackets to mount onto the chassis. As we cut down the chassis, these brackets are too long. As you can see in the picture, if you cut these brackets just behind the original screw slots, they will fit nicely on your chassis. If you don't have these aluminum brackets in your kit, you can easily make them from 3/4 inch wide thin brass stock found at a local hardware store. Cut the stock into sections 1 and 5/8 inches long. Then mark a line 1/4 inch from one edge and bend the stock 90 degrees. This bend can easily be done in a small vise. Next, we need to mount the brackets to the chassis. I like to mark the front holes about 1/3 of the way back from the front edge, so that we will have room later to mount our hall sensor used for lap counting. The rear holes should be near the rear edge of the mount. These dimensions are not critical. As we did previously, center punch the holes and drill them with the same drill we used when we mounted the 2 chassis halves together. I use the 4 screws and nuts left over from the original chassis to mount these brackets. You, of course, can use any hardware you wish. After all, this is your chassis build, and customization is highly encouraged. Align the bracket's front edge with the front edge of the chassis wing, as well as the outside edge of the bracket with the outside edge of the chassis wing. The rear edge of the bracket will hang over the rear edge of the chassis wing a bit. This is by design and will not interfere with the rear wheels, but give us a bit more bracket to chassis support. Drill one of the holes in the chassis wing. Then I like to use one of the screws and nuts to hold the bracket in place as I drill the other hole. This just helps keep everything in alignment. When finished, the brackets should be aligned with the front and outside edges of the chassis wings. The rear edge of the bracket will overhang the rear edge of the chassis wing. As said previously, this is by design. This is a good time to mention. If you're looking for missing hardware, especially small screws, washers, and nuts, look closely at your chassis around the magnets. It is also a good idea to watch these areas before any racing. You never know what may be hiding. Although there are many ways to hold the body onto the brackets we have installed, including screws and nuts as well as Velcro, I have found the best solution are these wire clips. There are many lengths available, but the 2 and 1/2 inch long versions work the best for our application. Old-school marking of the holes we need to drill into each of the brackets means very accurate measurements. The hole positioning on the bracket is not critical, but the distance between the center of the holes must be 2 1/4 inches for the clips to mount correctly and stay in place during a race. The drill size needed for these holes is a bit critical. I have found that a drill bit diameter of 0.044 inches works the best. But a number 57 or a 3/64 drill bit size are very common and will work well. Too small, and the clip will not pass through the hole. Too large, and the pin will fall out. Testing on a scrap piece of metal is always a good idea. There is another option that eliminates the careful measuring and marking of the holes, and this option I find is the most effective. Drill one hole in the bracket and put a pin into the hole using the Z-bend side of the pin. Then use the S-bend side to mark an arc on the bracket where the second hole is needed. This perfectly aligns the 2 holes in the bracket. No measurement needed. Drill the second hole anywhere along the arc. If your holes are properly aligned, the pin will snap into place and lie flat on the bracket. The Z-bend end of the pin should be in the front hole and the S-bend in the rear. Repeat this process for the other side bracket. We have now reached the point in our project to reassemble our chassis drivetrain parts. There is absolutely no reason you cannot use all the parts which came with the chassis. In fact, if this is your first brass chassis build, I would highly recommend that you use these parts. 2 additional cutting operations will be needed. One to shorten the front and rear axle shafts. We will no longer be using the black plastic spacers that came with the kit, and so the axle shafts are too long. We also need to cut off the rear motor shaft as it will interfere with our oxygen electronics module. Both these cuts can be made using the rotary cutoff wheel that was an option when we cut the chassis. In this operation, a hacksaw will not cut through these shafts as both are hardened steel. When reassembling both the rear and front axles, we can repurpose the small metal washers that were part of the screws and nuts that held the front and rear chassis parts together. The crown gear that is supplied with the chassis kit has 31 teeth. Depending on the height of your rear magnet, there may be an interference between the magnet's rear edge and the crown gear. Look closely to see if there is enough clearance so that the 2 parts do not touch. If they touch, replace the 31-tooth crown gear with a 30-tooth. This will not make any noticeable change with the car's performance and prevent damaging the crown gear over time. The front axle is assembled differently from the original setup. On the left side wheel, the locking set screw is removed. A 1/8-inch Dubro collar is held at the end of the axle by its set screw. This allows the left wheel and tire to freely rotate. The right side wheel is held to the axle with its normal set screw. And just like with the rear axle, 2 metal washers are used where we removed the larger black spacers. Tighten the right set screw so that there is no side-to-side play in the axle while allowing both front wheels to spin freely. There is a 3D printed green guide stop available that I highly recommend adding to your chassis. This will raise up the front end of the chassis with enough clearance that the chassis will not rub on the track. It will also stop the guide from turning past 45 degrees in either direction and make the car much easier to put on the track. When mounting the guide to the chassis, a thin washer is recommended to be placed below the guide nut. Any thin metal or plastic flat washer can be used as long as there are still enough threads exposed on the guide screw so that the nut does not work loose. The guide should move freely side to side without any binding, and should stop when it hits the green guide stop. You may have noticed that I am using a dark gray guide. There is nothing wrong with using the white plastic guide that comes with the H&R kit, but I am a bit lazy and like the performance of the Professor Motor PMTR 1131 graphite guide. As we need to sand the guide down to fit our track, it is much easier to do with this guide. Sometimes it is beneficial to make a tool to help us with our project. How you sand your guides down is entirely up to you, but I like to use a flatboard sander. This tool can be made by taking a piece of wood and gluing a piece of 220 grit sandpaper to it. Gluing the sandpaper to two of the sides allows us to have a tool that can sand on only one end or two edges at the same time. Folding the sandpaper over the second edge of the board makes a nice 90-degree edge for sanding. Finally, cut off any excess sandpaper with a razor knife so that you have clean edges. Any extra sandpaper which has glue on it can be used at this time to make an additional sanding block for other projects. Take your time and sand the thickness of the guide down on both sides using long sanding strokes. This will keep the guide sides parallel, and working on both sides a little at a time will keep the remaining guide material centered. You will also want to sand the depth of the guide down, testing on your track to make sure the guide slides smoothly in the track and does not hang up in your tightest turns. This sanding process takes time to get a smooth and fast-running car. The good news is that the front guides are easily swapped out, and you can try many ideas to find the one that works the best for you. This is all part of our hobby, tuning our cars. Another tuning parameter which must be done to make our chassis run correctly is to sand, or turn down the diameter of the front foam wheels. I like to use my drill and the sanding tool we made to do this. There are many ways this can be done, but I find this method very easy. How much material you remove is up to you, but I have found that when the car is on the track and the front tires just clear the track, spinning freely, provides the best performance. Here is a typical example of how much material I have to remove. It takes time to get just right, so keep testing your progress, putting your chassis on the track. If we were planning to run our chassis on an analog track, our chassis is almost complete. Adding 2 front braids with 2 wires to the motor, and we are ready to run. Of course, we still need to add a body, but this video is about building a brass chassis car that will run on digital tracks, so we have a bit more work to do. Although there are many digital car chips on the market today, I selected the Slot-It Oxygen Digital Systems C-chip for this project. It has many advantages, including that it will work with most digital systems on the market today, as well as it has a high current motor driver which will survive the higher motor current needed for these heavier cars. Most of the time, I mount my electronics in my slot cars directly to the plastic chassis. But in this case, with a metal chassis, there is the risk of short circuits. Never fear, a plastic chip carrier was developed which can safely hold our electronics. It also has the option of using a remote lane change LED and securely holds the LED in place. The chip carrier's design is slightly oversized and must be trimmed to fit in each chassis. This is very easy to do with either a file, sandpaper, or a very sharp X-Acto knife. Once trimmed to fit, the LED mounting area should fit into the square hole in the chassis behind the front axle. The bottom of the chip carrier should rest securely on the chassis rails. Before going any further, I want to mention what I believe is the best mounting material for electronics in slot cars. Blue tack is very sticky material while providing excellent shock absorption. I use blue tack both to hold the C-chip into the carrier as well as the carrier to the chassis. I always try to get the lane change LED as far forward in the chassis. This means I need to use a remote LED. These 5mm LEDs from Newark Electronics work quite well. Other infrared LEDs will also work, just make sure you follow the instructions found on the slot IT oxygen sight. You may need to drill a different size hole in the chip carrier or cut some of the carrier away to accommodate the size of your LED. Or maybe even use some CA glue to hold the LED in place. Again, these instructions are clearly explained on the slot IT site. In the end, you will use blue tack to hold the chip into the carrier after you have soldered the LED wires to the bottom side of the chip and to the remote LED. The final installation of the C-chip into the carrier should be nice and clean. This facilitates removing the carrier with the C-chip if necessary, in the future with no damage to the C-chip. Install the C-chip carrier into the chassis using blue tack and wire, the leads to the motor, and the front guide and braids. Then I like using double-sided tape to hold the Hall sensor flex tail to the underside of one of the side wings depending on which side of your track you place your lap counting and pit lane magnets. Connect the flex tail to the correct connector on the C-chip, and don't forget to close the black latch to lock it in. I believe this next extra step when making a brass chassis is well worth the effort. I am not fond of high spots found on some plastic tracks. These high spots can easily cause a short circuit between the track rails and the bottom of a brass chassis. To prevent this shorting, I prefer to put an insulator layer on the bottom of my cars to eliminate this potential. Using a thin plastic layer and a double-sided adhesive layer, which can be purchased on Amazon, a very solid insulation layer can be installed, which will prevent all chassis-to-rail shorting. Yes, this is a bit more work, but you will find well worth the effort in the end. I have tried electrical tape as well as mylar stickers for this insulation layer, but in time they rub through. Captain tape is another excellent protective layer and should be considered, but can be a bit expensive. Remember to cut a hole in the plastic insulator so that the LED light output is not blocked. Trace an insulator outline onto the adhesive layer and cut out the needed section. This adhesive is very sticky and can be difficult to work with, but does an excellent job of holding the insulation layer onto the chassis. Take your time and, if necessary, trim or cut a new piece to fit. When finished, make sure you press the insulation and adhesive layers firmly onto the chassis. And don't forget to cut out the hole for the LED. Rather than mounting the body, the digital chassis is now completed. You will need to register the C-chip on the Slot It website. There are many YouTube instructions explaining how to do this registration, so I will not go into it here. It can be a bit frustrating, but believe me, it is worth the effort for such a versatile car chip. Our chassis is now ready to test on our track. It is easier to make chassis changes now before we mount our body. Make multiple passes on your track to make sure the chassis tracks smoothly. Lanes changes correctly, and enter and exit pit lanes. If all works well now, it will work well with the body attached. But if there are any issues with the bare chassis, it is time to identify what is causing the issue and fix. Double-check your guide dimensions and front wheel diameter. These are two areas which make a big difference how any chassis works on a track. Adding a body to a brass chassis will not help resolve any issues, as sometimes happens with plastic chassis cars. The final step in making our brass chassis car is to fit the body to the chassis and paint the body. There are many RC car videos on painting these plastic bodies, so I will not spend time here detailing that process. However, if this is your first time painting this type of body, the paint is applied on the inside. This really helps protect the paint when rubbing is racing and keeps the car looking new for a very long time. Trim your body using small sharp scissors, making multiple passes until you get your body trimmed to your liking. I also find our sanding block helpful to make straight edges where needed, as well as a sanding disc on a rotary tool to make clean curves. Once you have your body rough cut, I like to mount it to the side brackets on the chassis. As you can see through the body, it is easy to line up the body and drill one hole. Then put one end of a pin in that hole to hold that alignment, and then drill the second hole. Do this for both sides of the body so you can see the final alignment of the body to the chassis. In the end, the clip should lay flat on the body just like it did on the bare side bracket. For my final trimming, I like to use a Sharpie to outline where my final cuts should be. Then remove the body and make your final trim cuts. Again, 90% rubbing alcohol works great to remove any markings left on the body. It is also good to give the body a good cleaning using this alcohol to remove any molding residue before painting. Remember to carefully clean the inside of the body, as this is where we want the paint to adhere well. There are two types of paint which work extremely well for these types of bodies, and I have listed them in the part list in this video. But be careful. Many types of paint will not adhere well to plastic bodies of this type. Paint your body, and when it is dry, usually overnight, mount it and you are ready to run. For normal racing, these cars will hold up extremely well and take some serious abuse. For safety reasons, I do recommend a small piece of electrical tape to cover the back end of the body mount clip. This prevents the clip from inadvertently popping out and ending up on the track. Congratulations, you have finished building your brass chassis car. Unless, of course, you find yourself racing with multiple attempts to make your cars go airborne or wheels up on the floor. These brass chassis cars, if set up properly, will race extremely fast. The brass chassis are almost indestructible, but I have found that under extreme crazy racing, the bodies can use some reinforcement. Sometimes just a layer of E6000 glue on the inside of the body is more than enough. But if you find yourself wanting more, a thin layer of fiberglass or fiberglass tape glued to the body with E6000 glue will make your car bodies ready to survive some serious accidents. As I stated during this video, here is the list of parts you will need to build your brass chassis car. I always recommend you support your local hobby shops. However, many of these parts are available online from Professor Motors Slot Car Racing and Slot Car, Saline, Michigan. If you want to upgrade your brass chassis car, I highly recommend trying many of the available parts on the market today. After all, experimentation and tuning of our cars is a large part of this hobby. Here are some of my recommendations which I have found to be well worth incorporating. I know that this video is long, but many of my local racers told me to keep it detailed. I hope you have enjoyed watching it and will take the time and effort to build your own brass chassis car. I will now finish, but before I do so, I want to thank a few people who made my journey developing these cars possible. Oliver at Professor Motors for always being there when I need a consultation and shipping me parts when I needed them. Brad for figuring out how to make the vacuum-formed bodies, which without these bodies, this project would never have been completed. To Maurizio at Slot IT for bringing out the oxygen C-chip. Again, which without this electronic part, this project would not have been possible. Ken for all the work in 3D printing multiple versions of chip carriers and front guide stops. Don for pushing me into video recording and helping to review my edits. Finally, to all those who have raced with me over the past many years, living through the trials and experiments from my first attempt at a brass chassis car to the design which we now race almost exclusively.